Parametric equations. Let's look at these junk cars being driven off a cliff. I shouldn't say driving. The gas pedal is being held down and it is just shooting off that cliff. No one is in there. Parametric equations do not have anything to do really with conic sections. However, it is an essential skill for you for next year. And basically what is happening as these junk cars are being catapulted off the cliff because the gas pedal is being depressed is you are taking two different forms of motion and we're going to create a single equation from it. So there you go. Now to the boring stuff, the stuff you love, the notes. All right, so basically up here, so where the SX is, that would be like how fast the car was just driving down the road. And then this y equals g of t, that would be, you know, where it's being pulled down by gravity and it's dropping and accelerating at the same time. We're going to put both of these data pieces together to create a parametric equation. So these outputs become dependent variables for another equation. So what we are going to do is we are going to take a look at this golfing example. For this golfing example, somebody hits a golf ball and that's the straight line motion. This is going to be the parabolic motion. We're going to graph these two pieces together. So we're going to take both of these and we're going to set it for a domain of time of 0 seconds all the way up to 5 seconds. So 0, 1, 2, 3, 4, 5. Okay, and we're going to plug these into both of these, and that's going to become our order pairs. All right, so when you plug in 0 to the first one, that turns into a 0. When I plug in 0 to both of these, that turns into a 0. When I plug in a 1 right here, 92 times 1 is 92. Over here, this is going to be 1 squared times a negative 16 plus 92 times 1, which is essentially going to be 92 minus 16. So that's going to turn into 92, 82 minus 6 is going to be 70 something. I think it's 76. But you know what? I'm just going to go over here and plug this stuff in and get my tables. So right here, I'm going to input a table. And that was 76. I was right. Okay, let's go ahead and write 76 here. I'm just going to copy the rest of the table. Remember, if you're doing this stuff on a test or a quiz, guys, I'm going to give you a calculator. All right, so we had 76 for 2. Go ahead and put in 120. Remember, we're in the Y column. Remember, this is the Y column. And we need 3. Let me type in 3. Okay, write that down for the column. Here's 4. One more. Here's 5. All right, so in your far right column, you should have 0, 76, 120, 132, 112, and 60. And I'm talking about this. Let me go to the screen real quick. You should have these down. We're going to do the same thing. Let's just go ahead and find the table in Desmos because we don't have time for a calculator. All right, let me go up here, put a calculator, or I'm sorry, put a table in here. All right, so we're going to use these for our other column. We already have 0, 0. You already have 92 for the X column. Go ahead and put in 184. And then let's figure out what 3 is. All right, write 276. 4 is 368. Whoops, not 45. Let me put 5 down here. And then 5 is going to be 460. So go ahead and write those down in that middle column there where it has the X above it. You're probably already done, but I'm catching up to you. Hold on. Almost done. Okay. All right, so there I have plotted that data. All right, so we're going to plot this data on the x-axis here. We're going to plot this data on the y-axis. And guys, let's maximize the picture of the chart. Let's see, we've got 0 all the way up to 460 for our x values. Guys, I'm going to draw 5 tick marks and let them be 100 apiece. 1, 2, 3, 4, 5. So these are all by a scale of 100. Because my largest one was 460. All right, let's take a look at what's going on here. I've got a large one here of 130. I'm just going to do in increments of 30, 60, 90, 120, 150. So 30, 60, 90, 120, 150. Okay, guys, let's plot these ordered pairs. So we got something down at the origin, 0, 0. And then 92, 76. 92 is before this. 76 is about right there. Remember, we're kind of estimating. 184, 120. 276, 132. 368, 112. And then 460, and then right on the 60 on the y-axis. Okay, so something pretty important with parametric equations and their graphs is once we plot these points, we're going to connect them because time is continuous. This is continuous motion. And we're also going to actually draw the direction of how the graph goes, because sometimes it goes backwards, which like sometimes it would start here and go here, but not in this case. We started here, and then this is how the curve shaped as time progresses. So that's called the direction, those arrows that I actually drew on the curve. All right, so let's go ahead and practice some non-story questions, just some straight computation. So on number 2, we've got a couple of equations here. For each pair of parametric equations, make a table of values, draw the graph and show the orientation, and then look, we're going to do an additional piece that we didn't do on the front. We're going to write an equation. To write an equation, very, very easy. You just solve for t for one equation and plug it into the other. Solve for t and plug into other. With domain. All right, so here we go. All right, so we're going to start with our domain. Our domain right here is 0 through 4, and look, it's brackets, which means we include 0 and we include 4. So 0, 1, 2, 3, 4. All right, I'll put my x values in this column. I'll put my y values in this column. When we plug in 0 right here, that's going to be 1 minus 0. And of course, that's just 0. When we plug in 0 right here, that's just going to be 2 plus 0, which is 2. When we plug in 1, that's going to be 2 minus 1. That's going to be 2 plus 2. Go ahead and plug these in, guys. We're just plugging these in and doing our mental math here. When we plug in positive 2, we're going to get negative 3. This is going to turn into a 6. When we plug into a positive 3, and then when we plug in a positive 4, this is a negative 7, and that's a 10. Okay, so let's go ahead and plot those on the coordinate grid. So we're done with part A, now we're doing part B. Let's plot this. So this is going to be a 1, 2. A negative 1, a positive 4. Negative 3, 6. Guys, just go ahead and continue to plot. All right, so there's the dots. And remember, you guys have to determine the orientation. So we started out here and then we went left. So I'm just going to draw arrows indicating that direction. Remember, you had a bounded domain. It started and stopped at 4, so no arrows. It's going to be like a line segment. There we go. All right, that's part B. Part C, write a rectangular equation. Okay, let's take the x equation. Take the x equation, solve for t. So we're going to move the 1 over. It's going to be x minus 1 equals negative 2t. I'm going to multiply both sides by a negative 1/2. All right, so t is going to equal and I'm not even going to distribute this. I'm just going to leave it like this, because that's going to get put into the y equation for the letter t. So remember, y equals 2 plus 2 times t, but this is t, so let's write -1/2 and then x minus 1 in parentheses. Don't forget, you kind of have a double parenthesis right there. Okay, let's definitely clean this up this time. Let's go ahead and distribute that 2 times that -1/2. That's going to be a -1. So y is going to equal 2 minus 1. And then don't forget, you still had an inside set of parentheses there of x minus 1. Let's distribute the -1. You got 2 terms in there. So this is going to be y equals 2 minus x plus 1. So y is going to equal a -x plus 3. Now, don't forget, that's your rectangular equations. The rectangular equation, x and y are on a rectangular coordinate grid. That's why they call it a rectangular equation. You always include the domain. But the domain, remember, are x values, which is this right here. So we're going to include the domain, but remember it comes from these values. So it's going to be 1, or no, it's not, lowest to biggest, -7 to 1. So remember that domain, I'm just going to kind of highlight it because that's really the trickiest part of today's lesson. Remember, this comes from that column. All right, let's look at problem 3. So for problem number 3, we're going to do the same thing all over again. Look at our domain. It's not really bounded. We're going to have an arrow. It starts at -1. We're going to have a closed dot at -1 for sure, but we're going to have an arrow because of that infinity sign. And so for txy, I'm just going to write -1, and I'm just going to fill in some numbers till I run out of room. All right, so I'm going to 3. So let's plug in values to both of these and solve and find our ordered pairs. When you plug in -1 here, it's going to be a -3. When you plug in 0, when you plug in 1, 2, and 3. All right, when we plug in these values, we're just going to square them, guys. So -1 squared, 0 squared, 1 squared, 2 squared, 3 squared. Okay, let's plot this and see what happens. Our first order pair is -3, +1. Okay, so I plotted those order pairs. Next thing I'm going to do is just indicate the direction. So we are going this way. That's the direction that we went. This is for sure a closed dot. But at the top of your graph, you need to draw an arrow because remember it goes on to infinity. Part A, part B, now on to part C. So we are going to take the x equation and solve for t. That's not too bad. We're just going to move that 2 over. All right, now we're going to take it and plug it into the y, and the y is squared. So this is going to be x plus 2 squared, and it's fine. You guys can leave it like that. You can FOIL it out if you want, but you don't have to. But what you do have to do is you have to write the domain. Now remember, when we plugged in a -1, we got an x value, a domain value of -3. But look, we drew an arrow, so it goes on forever. So don't forget, these values come from this column. All right, let's do this one more time. Actually, I'm going to ask you guys to do this and show me. Thank you.